difficult question, but you have all the skills necessary to answer the question, everything you've been taught and your prior knowledge. So when I first saw this question, didn't have much to work with. The only thing I knew is that the log of 162 to the base 3n was equal to the log of 2 to the n. Didn't really give me much to do, so what I said is I needed a starting point. So what I did is I split it up into the log of 162 to the base 3n and the log of 2 to the n. And since those guys were equal to each other, then I just said I'm going to let them both be equal to x. Because now at least I have a logarithmic equation to work with. Okay? Since they're equal to each other, I can set them equal to the same variable. Does that make sense? Can I do that? Okay. So the whole reason I do that is because now I at least have a starting point. Now I can take this and write it in exponential form, which I did incorrectly. And why did I do that incorrectly? Well, the reason is because I wanted to show you a common mistake. And can somebody tell me what I did incorrectly, writing it in exponential form?
If you only put n to the power of x, you should have put 3 as well.
Perfect. So I have to put that in brackets. Okay? Very good. Okay, so be careful of that. So the whole entire base is to the exponent. And on the other side, I get 2 n to the power x. So I have two equations. This is my first equation. 162 is equal to 3n to the power x. And my second equation is 2 is equal to n to the power x. So I have two equations. I have two unknowns. I have to solve two equations, two unknowns. So I'm going to take my first equation, and I'm going to distribute the exponent through so it goes on both of them. I'm going to take my second equation, and I am going to eliminate one of the variables. So this is reaching back to grade 11, right? Because this isn't a linear system with arithmetic where you can just add or subtract and get rid of one of the variables. We're dealing with exponential. So you have to reach back to geometric series when you did this. How did you eliminate one of the variables when you were working with geometric series? Can anybody recall? Better? That's when you have like the linear ones, right? Because you could take this, subtract this, you get one, but if I subtract this from this, I won't get rid of anything. Yeah. Yeah, you can do that. So if I put n equals n to the power x is equal to 2, right? So I could take that and I could substitute it into there. Perfect. Okay. What's the other way of doing it? And that's awesome. That's perfect. What's the other way of doing it? I just want to remind you, just in case you forget to do a substitution one. Yeah.
You can divide the first equation by the second.
Right. You can divide the first one by the second one, or do exactly what Brandon said. Either way, I'm just going to show you by dividing it, just because sometimes the substitution gets a little bit harder. Okay. So if I divide this, 162 divided by 2 is 81. And then 3 to the exponent x, n to the exponent x, divided by n to the exponent x, n to the exponent x divided by n to the exponent x is 1, leaving me with just the 3 to the exponent. Now that's an easy equation to solve. 81 could be written as 3 to the power 4. Once I have the bases the same, I can equate the exponent. Now I know what the value of x is. So I can go over here to equation number 2 and substitute x in for my value, and I get 2 is equal to n to the power 4. My whole entire question is to figure out what n squared is. How can I get n squared from n to the power 4? Okay. Divided by 2, and that'll get, so n to the power 4 divided by 2 is equal to n squared. So not divide by 2. I think you're on the right track. So what are we going to have to do to get rid of it? Right, square root it. So I'm going to take the square root of both sides. The square root of n to the power 4 is n squared. And the square root of 2 is the square root of 2, but remember you have to do a plus and a minus whenever you're taking a square root. N squared is the square root of n to the power of 4, and then my answer is positive root 2, because remember you can't have a negative base in the law, so that's why we omit the negative. That's the answer to the question. And you can do it exactly what Glenn said as well. Substitute this in here, you divide by it, and you get the same. Works perfect. Okay. Any questions on that?
Show us this.
Yeah, sure. So so from this step here, 162 was equal to, and 2 was equal to n to the power x, right? So Brennan's just saying if n to the power x is equal to 2, take 2 and substitute it in for n to the power x, so you get, and then divide both sides by 2, and you end up with that equation up there, down here, and you do the same thing. Which is perfect. Sometimes substitution becomes a little bit harder, that's why I wanted to remind you of dividing. Does that make sense? You end up with the same thing. Does it, guys? Yeah. Okay. So now we're going to get on to exponential growth and decay. So these are the word problems that you're going to be responsible for knowing in your tests. Okay, so the first thing we're going to talk about is what we already know about exponential growth. So exponential growth, remember that exponential growth happens when you have a exponential function where the base is a number greater than 1, right? So that you end up graphing it, and you get a function that looks like that. So as x increases, the function gets greater and greater. I can put a number out in front of it, and that's not going to change the look of the graph. I'm just going to have to stretch it and compress it. Okay? It's not going to change any asymptotes. It may change the intercept, but that doesn't matter. Okay. So this right here represents exponential growth, and the B is known as the growth factor. So the growth factor is always a number greater than 1, because it has to be greater than 1 in order for you to have exponential growth. The base has to be. So if the question says, well, it has a growth factor of 7, then you put 7 in for the B. A lot of the times, though, it doesn't give you as a growth factor, it gives you as a growth rate. And it gives you, if it gives you a growth rate, then we're going to use this equation. So the R is the growth rate, which is given to you as a percent. So what you would need to do is take that percent, change it to a decimal, and then add it to 1, because the base has to be greater than 1. The other variables, the Y is the final amount of whatever you're dealing with, money, population, whatever it happens to be. A is the initial amount, whatever you start with. And then X is the number of growth periods. So if the question's given to you where they give you the growth factor, and then again, you just have to read the question. If it gives you the growth factor, you use this equation. The A, the Y, and the X mean the exact same thing it does here, but the B is the growth factor. If they give you a growth rate, and you'll know because it's a percent, then you use this formula. Okay. Exponential decay. So you have an initial value, but this time your base has to be a number between 0 and 1. So if the base is a number between 0 and 1, if you recall, we got a graph that looked like this. So as x got bigger and bigger, the function got smaller and smaller, closer to 0. And this is my decay rate. excuse me, my decay factor, almost rate, and factor. And if they give you a decay rate, remember that the b has to be between 0 and 1. So it's almost the exact same equation with the exception that you're going to subtract off the rate because you need the base to be less than 1. But everything else means the exact same thing. The y is the final amount, the a is your initial amount. In this case, though, the r is the decay rate. And the x is the number of decay periods as opposed to growth periods. Okay, so basically these two equations can be used for any type of exponential growth or exponential decay. The only one that it can't be used for is half-life, and there's a particular formula for half-life, which you don't have to memorize if they give it to you if you need to use it. Okay, and there are examples in your guide dealing with half-life, and you can ask me if you're unsure what questions involving half-life. Okay, so typical example that you'll be responsible for knowing. Okay, so question number 1 is how long will it take a population to triple if the growth rate is 1 7/8% per annum? So per annum is just another way of saying per year. So in the context of the question, you have to decide whether it's exponential growth or exponential decay. Obviously, it's growth if it gives you the growth rate. So then you would start with the, and again, the variables don't matter. Like I don't have to use y. I can use any letter I want. Is that it? The plus does matter. Thank you. But the letters don't matter. Like I can use anything. I could use I here. I could use Q. I could use T here. It doesn't matter what it is. Okay. So all you have to do is identify each one of the variables, substitute it in, and solve for the unknown. Okay. So in this case, we want to know how long it's going to take. So which variable am I trying to solve for? X. So I'm trying to figure out what x is. Okay, so then I should know, if I'm trying to figure out what x is, I should be able to figure out what r, a, and y are. Let's do r, because this is by far the most common mistake people make on the test. They cannot take a number like this and write it in decimal form. Right? Because if you can do that, the question's really easy. So 1 7/8%. So you have to change that to a decimal number first. So the first thing I'm going to do is convert my 1 7/8 to a decimal. What would 1 7/8 be as a decimal? Yeah.
1.875.
So if you're unsure how to do that, you can just take 7 divided by 8, add it to 1, and it'll give you that. Okay? So this is not a decimal number. It has a decimal in it. It's not a decimal number because of the percent sign. All we did is we converted this to this, but we haven't gotten rid of the percent sign yet. How do I get rid of that percent sign? Okay. Now multiply by 100, right? So I have to convert my rate, which is a percentage, into a decimal number. A decimal number doesn't mean it has a decimal in it. A decimal number means it doesn't have a percent sign. Okay? So this is not a decimal number. This is a percent sign. This is a percentage. This is a decimal number. Okay? So the first thing I'm going to do, now that I've figured that out, is substitute that value into here. Okay, now I need to figure out what the initial amount is and the final amount is. It didn't give me an initial amount, okay? All I know is that I want the population, I want to figure out how long it's going to take the population to triple. So what do you think I can use for A and what? Okay.
For A, you use 1, and for Y, you can use 3.
Excellent. Okay. You can pick any single number in the world for A. You can pick 100 and then just triple it and put 300. Okay. If you pick 7, make that 21. Okay. You don't care what the initial population is. All you care is that you're able to multiply it by 3 to get the final population. So that's the important part of that ratio. Does that make sense? Okay. So now it becomes a matter of solving this simple exponential equation. Okay, so the 1 I don't have to put in front of there anymore, and adding the 1 to the rate inside of the bracket, I get that. Solve an exponential equation where the bases can't be made the same. I take the log of both sides. The reason I take the log of both sides is because I can take that exponent, which is on that number, and move it down in front. And then isolating the x, I get the log of 3 divided by 1.01875 is equal to x. X is approximately equal to, somebody tell me what x works out to be? Anybody get that? Rebecca? And then just write yourself a therefore answer or statement. Therefore, it will take about 59.1 years. So the hard parts for these exponential growth and exponential decay questions is to be able to convert this into a decimal, and then just identifying your A value and your Y value. A lot of the times the A value will be given to you, but if it's not given to you, remember you can start with any A value and then do whatever it needs to be done, tripling it, doubling it, whatever it happens to be to put the proper final. Okay? So let's just try another one. So a car depreciates at a rate of 9.75% per year. How long will it take for the car to be worth 1/5 of its original value? So again, in the context of the question, you try to figure out if it's exponential growth, exponential decay. The word depreciate should give you the hint that it is exponential decay. You're trying to figure how long it's going to take something to do it. So you're looking for the x value. So we can figure out the rate. Remember the rate, and again, this is the most common mistake people make, so please do not make it. Okay? You have to take 9.75% and make it into a decimal number. So the first thing you do is take 9.75 and change it to a decimal so that you get the decimal percentage, and then divide that by 100 to make it a decimal number. Once it's a decimal number, then you can plug it into the formula. Again, they don't give us what the car is initially worth. All I know is that I want to figure out when it's worth 1/5 of its original value. Okay, so all you need is a starting point. So what's a good starting point for the card's original value? Okay. So if it was 1, then what would its final value be? 0.2 or 1/5, right? Okay. Just get in the habit, like you could use 0.2 because it's a terminating decimal, but if this was 1/3, I don't want you to put it as 0.33 because then you're rounding it off. So just get in the habit of leaving it as the fraction, okay? And again, you can use any value. If the car was originally worth $5, then you can figure out when it was worth $1. If it was worth 5,000, figure out when it was worth 1,000. Does that make sense? Figure out the A and the Y value? Okay, because I'm doing harder examples because in the easier examples they give you the actual original value. Okay. Once you've done that, now it's just a matter of simplifying inside of there, which would be, what's 1 minus that? 9. Is that right? Yeah. The exponent x, because once you put in the variables, the equation should be very easy to solve. You're just taking the log of both sides. The reason we take the log of both sides is to move that exponent down in front. Comes the log of 1/5 divided by the log of 0.902. Oops. Yeah, 25. And x would approximately be equal to 15.69. So therefore, it would take approximately 15.69 years. Okay, so if you understand these examples, you'll be very good for the ones on the test. So the most common mistake people make is messing up the R value. Okay, remember you have to change it to a decimal. Okay. The very last thing that we're going to do in today's lesson is working with the TI-83 calculator. So it's important that you know this stuff and that you're able to do it, so I want to expose you to it. But remember that in this course, there'll be no graphing calculator questions on tests. You can never use a graphing calculator on any test. So if that's the only calculator you have, you should be using a different one for a test. Okay? But it's important that you understand the skills to use it and how to come up with it. So we'll do an example involving the TI-83 calculator. Because we can always ask you questions where I give you some information, you can tell me how to do it or something like that, right? Without actually using the actual calculator. Okay, so the data shows the growth of an investment. So the investment deals with time, which is in years, and an amount of money, which is in dollars. So you invest money, $2,500 to be exact. And then after 3 years, your money has grown to $3,238. After 4 years, it's $3,529. And after 6 years, it's $4,193. What I want you to do is to come up with an exponential model that represents this data. And then once you do that, I want to figure out how much your money you would have after 10 years. So we're going to determine...
Please excuse the interruption, but any student with the last name starting with Q to Z, if you could please go to the auditorium now for, if you missed the first picture day, if you bought a package but want to return it for a retake, if you want to order a package today, or if you need a lost student card reprinted. That's the last name starting with Q to Z. Please go to the aud now. Thank you.
Great. So then I want to determine an exponential model for the data and then determine the amount of money in 10 years. So again, you can do this algebraically. You're not responsible in this course to do it algebraically. You're responsible for being able to do it using a graphing calculator. Okay? So what you would do is take out your graphing calculator. Turn it on. First stat, and then edit, and then enter your data. So your data was 0, 3, 4, and 6. Do not enter any data that you don't have information for. So we don't have information for the 10th year. So we're not going to enter it. Then the amount of money is 2,500. Enter 32, 38. Enter 35, 29. Enter, and then 41. So now I have my data in the graphing calculator. I want to come up with an exponential model. So this is where I'm going to use my regression. Back in grade 9, you would have done line of best fit and used a linear regression. So you hit stat over to calculate. This is the one you would use in grade 9. In grade 10, you would have used a quadratic. We want an exponential one. So if I move down, you can see that 0 will give me my exponential regression. If I hit 0, and it gives me the formula. So the exponential model for this data would be y is equal to the initial amount. Now remember, my initial amount was $2,500. The calculator is giving me a different initial amount, so it's kind of rounding off. It's trying to come up with the best equation for it, and it's not a perfect equation, so just make sure you put the initial amount in, and then the b value we can just round off to 2 decimal places. So this is the equation that represents this investment. And if I wanted to figure out how much money I had at 10 years, what would you do? Huh? Who said it? Sorry. Yeah. I always ask Rebecca, so what I'd ask me different. Okay, so then do that, and on your calculator, you can do that all in one step. So you would go 2,500, bracket 1.09, bracket to exponent 10, and that would give you an investment of $5,918.41. So if I asked you another question, said, what was the growth rate for this money? What would you say? What did I invest my money at? Yeah. Right, 9% per annum. How did you get that? Remember that this right here represents your growth factor. Then the number added to 1 is your growth rate, which is 0.09. Change it to a percentage by multiplying it by 100. Make sense? Okay. So I'm going to save this.